It'll work. Sometimes I get interested in the small computer or the machine or some question about resistance or something. Excuse me.
What would you say is the most difficult problem in all of physics that you can visualize?
What, you ready to work on it? We have a very large number of problems in physics that are not this kind of problem. This is a game engineering problem because the sizes I've used are well within the realm where there is not much uncertainty. And there's technical problems of making it which are interesting, but not the most important problem in physics. If you mean by physics fundamental physics or the laws of physics, then the more important problems have to do with discovering the places where we don't know the laws, okay, which is a detailed thing which is outside of the subject, would take me some time to explain. I will be happy to do so at another occasion, sir. Okay? See, my group is a tough group. Yes, these are members, yes. I get one that's like Pistons, you know. If Steve's not, he'll think of something else. Yes.
At the end of your book, you mentioned your book, characters.
Which of the various books?
The one you autographed for me.
Oh, that
book. Yes.
That for me.
You mentioned that you thought there would come a time when the excitement of what was going on in physics would slow down because things had been discovered, and your analogy was
at least a
tourists discovering an otherwise beautiful area, and it becomes less interesting and less nice as more people know. That book was written 20 years ago. Do you think that's happening?
No. Well, it's true that the experiments are going more slowly, and each experiment is more difficult than the one before, and information is coming in slower. Nevertheless, I made a mistake. I thought, therefore, that the theorists would have less to work on, and therefore they wouldn't be quite as interested. But I didn't realize the propensity of human beings to speculate. And so, as a matter of fact, when less data comes in, more theorists are working with more crazy theories than before. And I hadn't contemplated that because in my day things were more vigorous. When we got a theory, we could check it. Nowadays, since the data comes in slower, we have much more fun making large amounts. I see everybody's getting ready. See them sneaking out there? So I think we should, let's do it this way. Let everybody who wants to go, and if someone wants to stay, I'll answer some more questions for them. But those who have something to do, because there are other interesting activities in this wonderful, wonderful place of Esalen. So I'll come back to it in a minute, but wait, let's the others leave who wish to leave, and then we'll come back to those who have some questions yet. Oh my God, so many questions. She had a question. I ought to answer hers first.
Well, it's something about the time that's coming when all the things are going to fit together and we're going to have all the answers and we won't need physicists to...
We don't know whether that's true. It's possible, but we don't know if it's true.
It's possible
still. Either thing is possible. Either that we find all the laws, that is to say we find laws, and as we check and check and check, everything fits, everything fits, everything fits, and it looks like we're done, and maybe we would be. Or it's possible that the data comes in slower and slower, like when you fall asleep or something like that. Not really, it doesn't go slow. But people get tired of it. There's too many new things and they not have any application, and it's too far out, and it's too expensive, and the high priests who are involved in it are not supported it much, and there are less and less people doing it. That's another way that the fundamental physics can stop. But applied physics, like discussions of matters of this kind, will go much longer than that, because there's all kinds of applications of the laws we haven't thought of yet. We're talking about two things: finding new laws, that is discovering new things about nature, and the other is finding new ways to use what we know. The second one will go on much longer than the first, and I cannot envisage how it stops. But the first one I could imagine, either that we get the answers or that we don't get the answers, and we don't get the answers but we're frantic all forever, thousands of years, or we don't get the answers and we give up. Or we get the answers, and that's all obvious. I can't see any other possibilities. It's obvious some other possibility is what's going to happen. Yes?
You see, as the laws of physics, when you talked about the heat engine, and because the cooling rate...
Right. That's all at the scale that we know the laws.
Well, if you wanted to make a heat engine,
yes,
what other mechanism would you use? Because you've got to follow some sort of cycle.
Yes, but there were many cycles of magnetism, of magnetized, the nuclear magnetism, for example, in the atoms and so on. There's many other things. The heat is at random motion, but the random motion of what? It doesn't have to be the motion of molecules bouncing, like an ordinary heat in an engine, but it can be the heat of spin, that is magnets swishing up and down, although the atoms that they correspond to are staying in place, and so on. So there are different scales at which we can get the heat operating systems and reversible cycles, if you want. But I use the internal combustion engine to illustrate that a particular type of engine, internal or heat engine, is not necessarily the way to go. We might get a clue from living creatures which do get their power from chemical reactions, and you might call them heat engines or not. They are in a way, but actually, so it's hard to answer exactly. We don't know exactly what you want, but I don't need to follow any particular type of engine, you see. I use different combinations of the laws. Yes, sir. I put you down once. Let's see if we can do it again.
I wonder, the power to be in physics.
Power to be
in physics. Will put a new original thinker to the stake and burn him alive because the earth is flat.
After all. Well, I think not, but perhaps I'll be the guy that gets burnt because the earth is flat. I'll take the risk. Right.
I want to go back to something in this drawing that
wasn't clear? No, it wasn't very
The one thing that I'm not clear about is that scale.
Yes.
What is it that physically makes light impossible to be reduced any further?
Light. Light is like, let us consider